Hello, welcome again to the second episode of Newpedia lectures. We are going to talk today about the mechanical ventilation, just a simple approach, bedside management basically. I understand there is lots of lectures regarding mechanical ventilation in neonates, but I'm trying to make it as easy and as quick and as memorable as possible. Let us start. What's the whole purpose of mechanical ventilation condition? So, how we're going to control that? So, basically, it's through increasing either the oxygen supplement through the ventilator by increasing the FiO2 or via increasing the MAP, which we're going to talk about later on. So this is the main airway pressure, which basically controlled by the elements which we see here, the PIP, PEEP, I time, and expiratory time, and the flow. The other thing is the CO2 removal, as we said, and that's actually the main job of the mechanical ventilator. Is to remove CO2. So this will happen basically by increasing the delta P, basically, which is controlled by the PIP and the PEEP. And as we see here, this formula, the minute volume actually is this results of multiplying the respiratory or the ventilator rate and the ventilator tidal volume, basically, which is here. Okay, so if you're going to increase, so you're going to increase the area, so this is your PEEP, and if it goes up, so you're going to increase the area below the curve, and this will affect your oxygenation, and that's really important bit. Okay, so so this volume is estimated to be between 4 to 6 mL per kilogram. So this is really important, especially in the volume guaranteed mechanical ventilator. And the basically the minute ventilation, which is the most important bit, and this is how we're going to approach any mechanical ventilator, whatever the brand is the minute ventilation. So it's basically the volume of gas moved in and out in 1 minute. So if it's, for example, the tidal volume of 4, okay, and the respiratory rate or the ventilator rate, sorry, is 60, so you're going to remove about 240 mL per kilogram. So mLs. And in liters, this is going to be 0.2 liter. Okay, that's really important because the next slides we are going to explain why it's really important to remember these figures. Is 200 to 300 mLs per kilo, or 0.2 to 0.3 per kilogram. That's really important. Okay, so we have talked about this curve already. So this is the tidal volume. Okay, I'm not going too deep into explaining all the FRC, the capacities and things. I don't want to make it complicated. Let us concentrate on the practical or the clinical bedside approach. All right, going back to the CPAP. CPAP basically will help to reduce the lung atelectasis because it will inflate the lung well. And it's going to improve also your respiratory drive and reduce the apnea. That's why we use it in apnea more likely than we use high flow, basically, although there is no major evidence to support that, but this is our usual practice. And it's a useful step down from the ventilation, and again, this depends on the unit which you are practicing this kind of ventilation modes. What are the risks? I think we're all aware of the risk. You're blowing the lungs like a balloon, so there is a risk of overdistension, and there is a risk also of pneumothorax due to that, and also there is a risk from the CPAP mask to cause any trauma to the nose or the nasal bridge, mainly. The next mode of ventilation is the BiPAP. So maybe it's as simple as CPAP, to be honest. So BiPAP, simply I will explain it at two CPAPs basically. It's the same machine usually will be able to deliver either CPAP mode or BiPAP mode. So a CPAP mode is just a single continuous pressure to provide continuous PEEP. But in the BiPAP, it will produce the CPAP, as we said previously. It will produce the continuous pressure to maintain the PEEP, but it will produce intermittent higher pressure than the CPAP pressure. Okay, and this will help. So basically, it will be a two pressure level ventilation in this condition. So you have to set, like, for example, you are given PEEP of 6, so this will be your minimal pressure, okay, and the other pressure, and this will be continuous basically. The minimal pressure will be continuous PEEP of 6, for example, centimeter water, and the other pressure will be higher pressure basically. So it will resemble the PIP, okay, the peak inspiratory pressure, and this will be basically intermittent pressure, not continuous pressure like the other one. So basically you're setting the rate because it's intermittent, so you need a rate in this condition. So you will set a rate, for example, on 30, 40, whatever, all right? And there's also an inspiratory time which you can control. This will help to reduce the apnea, and we find it like a step up from the CPAP if we find there is a kind of apnea is happening even on CPAP. Again, I'm not going through the evidence or more information about that. Let us just concentrate on how it works in this condition. So again, the same problem with the CPAP can be caused by BiPAP, and usually the BiPAP basically it's not synchronized, so there is no kind of synchronous breathing with the baby's breathing, so that's another problem also. Next, that our mechanical ventilators modes basically. So we have these modes, SIPPV, or as in Draeger ventilators they call it basically PCAC, assisted control, and the other mode is the synchronized intermittent mandatory ventilation. So basically it's SIMV, and also there is pressure support, PSV, and plus minus how the ventilator, if the ventilator can give volume guarantee basically. So basically it's either pressure only, which is SIPPV or SIMV or PSV, or pressure and volume, okay, which is the common practice here in the tertiary units in the United Kingdom. Be on SIPPV, which is the synchronized intermittent positive pressure on a very sick baby who's not breathing, HIE for example. So definitely we're going to start on SIPPV, which is the basically is going to support the baby's breathing, all right, and also is going to support any extra breath. But if the baby is well, so you can start the baby on SIMV, all right, and then you just try to wean it down gradually before extubation. So this is usually what we do: start with SIPPV or PCAC first, and then if the baby is getting better, switch him to SIMV ventilation before extubation. Okay. So coming to the settings in the ventilator, as we said previously in the initial curve, so basically all the settings is mainly the PEEP, okay, and the I time, which usually is 0.3 to 0.5. And if you're going to set the pressure, so you're going to set the pressure of a preterm, for example, with RDS 18/4, and mainly you need to look at different things like the chest expansion, and you need to look at different parameters like your for example saturations and the blood gases and lots of things. You're going to set the I time, as we said, between 0.3 to 0.5 seconds, and the flow of the ventilator should be 8 liters per minute at least. And you're going also to set your rate and your FiO2. So monitoring the baby's response to the mechanical ventilation, as we said previously, is the through the chest wall movement, respiratory patterns, saturations, and gases, and also the respiratory parameters. And this is the whole purpose of our lecture today. So your tidal volume, as we said at the beginning of this lecture, should be between 4 to 6 mL per kilogram. And your minute ventilation should be between 0.2 to 0.3 per kilogram. So this is your minute ventilation or minute volume, all right? And as we said, this is your tidal volume multiplied by the rate. And you need to look at the flow graphs, and you need to check if there is any leak. So I'm not going into the flow graphs or the leak, but I need to concentrate mainly on your minute ventilation. So for example, if we give a baby, which we're going to talk about later in the next few slides. Actually, I'm giving a few examples just to make sure that you can remember easily. So for example, this is the Draeger ventilator here. So you can see the minute volume, which is basically created. So this MVE here, which you can see, okay, and that's 0.18, for example. So this is the result of multiplying your tidal volume and your respiratory or ventilator rate, basically. So for example, this is here, that's the 40. This is your down there, that's the respiratory rate. This is what you sit through the ventilator, and you can see here up there in blue 43. So this is nearly, so the baby is not breathing more than what you're giving, and this is basically PC PSV, that's pressure support ventilation. And you can see here the FiO2 down there 21%, and your PEEP is 4. And basically this is volume targeted ventilation, all right? So that's 4 mL here. So which we said it should be 4 to 6 mL per kilogram. So if the baby is 1 kilogram, for example, like in this picture here, so it will be only 4 mL, okay? That's your rate, and that's your PEEP, and followed by that is the rest of the numbers, okay, what you said, basically. So quiz time. So you have a 26 weeks old, and his weight is 1 kilogram exactly, and you can see the ventilator settings here. So the pressures, PEEP of 20/5, and in air, and the respiratory rate is 50, so, or ventilator rate basically, and your minute ventilation is 0.2 liter per minute. But your saturations are 85% only. So, and this is your gas down there. So what do you think is the problem then? So basically this gas is in kilopascal. So you can multiply it, I think, by 7.5, so you can get the number in millimeter mercury. So so what do you think the problem is in this condition? Okay, exactly. So the problem is the low saturations. Okay, so basically you have 85% saturation here, which is not good. All right, so what do you think you can do? He's 1 kilogram again, just remember that. And you remember from our previous slides, this baby should have a tidal volume which is 4 to 6 mL per kilo. Okay, so basically it's 1 kilogram. I made it easy for calculation, so it should be 4 to 6. Okay, so your minute ventilation should be 0.2 liter. Okay, because this is what you get from multiplying your tidal volume in your respiratory rate or ventilator rate. So it's going to be 0.2, which is appropriate because he's 1 kilogram. So it should be 0.2 to 0.3 per kilogram. Okay, so that's easy also. So you have only one thing here, which is the FiO2 in this condition. FiO2 is only 21%. So maybe you can just only adjust your FiO2, increase your FiO2, so you can fix the 85% saturation here. Okay, so the solution would be basically increasing your FiO2. Okay. The next example, a 34-weeker whose weight is 2 kilogram, and he's being ventilated on SimV, and his pressure is 18/5. Okay, and the FiO2 is 70%, which is quite high, and his ventilator rate is 60, so you can't go higher than that. And his minute ventilation is only 0.12 liter per minute, and his saturation is 85%. So what do you think you can do in this condition? I have also attached the gas here down there, and you can see that the oxygenation is not great really. It's 4 kilopascal, and the CO2 is 8, which is high. Okay, so what can you, and you can see the pH is acidotic here. So what you can do in this condition, okay, or what's the main issue now is the low saturations and the high CO2. All right, and what you can do in this condition, what can you play with? All right, okay, so yes, that's right, you can increase your PIP, sorry. Okay, so you can see in the curve again, we can review that. So you can see this is the pressure time curve. All right, and this is basically what you have done. You have fixed things very easily by increasing your PIP, because by increasing your PIP you have increased your tidal volume or delta P. Okay, and this will help you with your CO2 clearance, but in the same time you have increased the area under the curve here, and by increasing the area under the curve you have helped with oxygenation too. Okay, next quiz, 37-week, 3 kilogram. So I'm trying to give you like easy numbers here. So 3 kilogram is on SimV, and his pressures are 26/4, but the FiO2 is high, 65%, and he's on a respiratory rate of 60 per minute, and his minute ventilation is 0.3 liter per minute. Saturations are 85%. And this is the gas here. So the gas looks, so there's low oxygenation in the gas here. PO2 is only 4 kilopascal, but your CO2 is 4.5. So what do you think here? You have a problem here? So you don't have a major problem basically with the CO2. It's even lower than, but you still have a problem with oxygenation. You're still on FiO2 of 65%, achieving only saturations of 85%. So your problems will be the low sats and the low CO2 to less extent. So what do you think you can do in this condition? Great, increasing the PEEP. Okay, because by increasing your PEEP, you have fixed the two problems. Okay, so going back to the curve, you have increased your baseline here, that's the PEEP. So if you increase your PEEP, okay, and you have a low CO2 problem, so you have reduced also the tidal volume or the delta P. Okay, so if you reduce your delta P, you have reduced your CO2 clearance, and you remember the CO2 was only 4.5 in this condition. Okay, and you have helped with oxygenation at the same time, because you have increased the area below the curve, which is really helping the oxygenation in this condition. Okay. The last quiz, again, a 33-weeker, 1.5 kilograms. So I'm going to make it a bit difficult in this condition. And SimV, he's on SimV, pressure is 28/5, and oxygen is 24%. The respiratory rate is about 40, and your minute ventilation is 0.15 liter per minute, and the saturations are 92, which is about okay. So, and this is the gas again, which is slightly, I would say, I would say it's acidotic, and the O2 is 4 and the CO2 is 10. So it's mainly respiratory acidosis in this condition. So what's your main problem here now is the high CO2 basically, which is causing low pH respiratory acidosis basically. So what are you going to do in this condition? So would you increase the rate, or increase the PIP, or increase the PEEP, or reduce the PEEP? Okay. Yeah, increase your rate, okay? Because basically, if you check here, the baby is 1.5 kilogram, and you're just giving a minute volume of 0.15 liter per minute, which is not really great. And your respiratory rate is 40, okay? And your FiO2 is 24%, which is not bad. It's not on very high oxygen requirement. So the best thing to do in this condition is just basically increasing your rate, okay? Because if you increase your rate, you're going to increase the number of these cycles here, up and down. You can see all these curves, okay? So you're going to add more curves. So basically, you're going to improve your CO2 removal, because you're giving more frequent clearance for the CO2, okay? So in summary, as we said, the oxygenation, the whole purpose of the mechanical ventilator is the CO2 removal and oxygenation. And as we said, the oxygenation will depend on the PIP, PEEP, the I time, the flow, because these are the elements which control your map. But in the same time, also the CO2 removal will depend on your minute volume, okay, or minute ventilation. So basically, which is the delta P, okay. Okay, that's the curve again, because this is really important. If you remember this curve, you're not going to lose your way. Okay, so basically that's it, which you can see here. That's your curve again, please remember. Okay, so the area below the curve is controlled by the PIP and the PEEP, and your flow, and also I time and the expiratory time. The other thing is the CO2 removal, which is controlled by the whole area. So this is the area between these two curves, are the tidal volume, and multiplied by the respiratory rate, this will create your minute ventilation. Okay, thank you very much. Please feel free to ask any questions in the comments. Thank you.